This is a typical exam type of question. The first step is to write a balanced equation. To do this, we make sure that the number of atoms found on the reactant side is equal to the number of elements found on the product side. To balance this equation, we need to put a 2 in front of the sodium, because then we have 2 sodiums here and 2 sodiums there. If we calculate the carbons, we've got 2 carbons here and 2 carbons there. If we calculate our oxygens, we've got 4 oxygens here plus 4 there, which is 8. And here we have 4 plus 2 plus 2, that is 8. Again with the hydrogens, we've got 2 hydrogens here plus 2 hydrogens there, which is 4, plus 4 hydrogens here, which is 8. On this side, we have 8 hydrogens. Go through balancing equations with your students for revision. Often, if a student cannot balance the equation, they generally get all calculations regarding that question incorrect. Step 1 is always balance the equation. Next, we look at what information is given. We are given the volume of sodium hydroxide in cubic centimeters. We're given the concentration of H2C2O4 with 2 parts of water, and we're given the volume again in cubic centimeters for H2C2O4 and 2 parts of water. The first question looks at what is a known concentration. What is a standard solution? A standard solution is when the concentration is known. This question is something that students can learn. It is just theory based, and they need to understand this. They will find this in their textbooks, in the CAPS documents. It often comes out in exam questions. The reason why an experiment is done over and over is always to improve the accuracy of results. The more times an experiment is done, the more results you get, and then you can take the average of that result to find out a more accurate result. This question is also often asked in exam papers to test if students have done experiments more than once and found the same result. Question 3 looks for the concentration. It looks for the number of moles. This is a simple calculation. We use the formula C is equal to N over V. We are looking for the number of moles of H2C2O4 with 2 parts of water. We have the concentration 0.02. We have the volume 25, but it is in cubic centimeters. We always work in cubic decimeters. So we divide by 1,000. We are solving for the number of moles. After we have used the formula, substituted the values, we then manipulate the equation. Once we manipulate the equation, we find the number of moles to be 5 times 10 to the minus 4 moles. Teach your students to use scientific notation on their calculator. This is really important. We will be using this equation for a more difficult question in question 4. Pay attention to what you have done already so that you can follow in the next question.